Okay, pre-cal, this is the homework for 10.6, the parametric equations. And I should have this ready. Let's get a couple papers as long as I'm here. Here we go. So I don't remember what the homework is other than it was 9 to 45, and I'll check again after that. Here we go. So we have, on the ones that say to graph it, yes, to sketch the maybe I'll do it on the first few, but you're not going to have to. I'm not going to expect you to do that on the test. So let's go with no, but I'll do it on the first few just to show you how you would do that. And this is the year 2022. So if it's some other year that you're hearing this video, I will tell you that the level of difficulty that I'm going to give you is something that is linear in nature, which would be something like 7 through 10, like this easy. Because you can see when this is squared, I'm going to tell you what I'm going to give you on the test is not that. Now, don't count on that being the case in some other year other than 2022. All right, here we go. So for this one, it's 9 is the first one. We're doing multiples of 3. So what you got to do is you have to get this in terms of this is 2 parametric equations called a set of parametric equations. And you want to write this as one equation in rectangular form. So you can see you got x in terms of t and y in terms of t, and you want this to say y equals some x here. So all you have to do is solve for t and then substitute back in. We're going to do that right now. This is going to be, if I add a 1 to both sides of this one, this would be x plus 1 is equal to t. And now I can substitute that value back in for t, right back there. And this comes up to be y equals 3 times, and instead of t, instead of that t right there, I'm going to, what is t equal? It's x plus 1 plus 1. Now we can distribute the 3, number 9. Should have written this. It's going to be y equals 3x plus 3 plus 1, which is y equals 3x plus 4. Now, you could graph this, right? This is a line. I will say this. Let me show you this. How I showed you to do this in the lesson. If you watch the lesson videos, I said you make a t, x, y table, and you start picking values. 0, 1, 2, 3, 4. Let's go to 4. And you start substituting in values for t. So with t and x are the same. So t is 1, x is 1, t is 2, x is 2, and so forth, right? T equals x. And now you have to substitute back in. Here we go. When t is 0, y would be 0. When t is 1, it would be negative 4. Excuse me. When t is 2, this would be negative 8, negative 12, and negative 16. And then you'd plot these x, y values. You get the idea. Okay. Give me a second. That's not the line that I have here. It has a y-intercept of 4 and a slope of positive 3. So something's not right. Let me look at it real quickly. Give me a second. Let me pause. Okay, guys. What I did wrong, let me cross it out on the table, is I was substituting back into number 7. We're doing number 9. I was using number 7. Let's do it again really quickly. And this would be t, x, and y. And again, we'll do 0, 1, 2, 3, 4. And so if we substitute in for t, a 0, that would be x is negative 1, 0, 1, 2, and 3. We substitute in those t values here to find x. And then if we substitute these t values in, let's do that. 3 times 0 is 0 plus 1 would be 1. And 3 times 1 plus 4. And it's going to be 2 times, that's 6 plus 1. 7. You can see it's plus 3, plus 3, plus 3. This would be 10. And this would be 13. And then you could plot those points, and that would get you the motion. Okay. Now, I think I'm going to not do that anymore because you will not have to graph, but that's how you would do it. That's how you would do it. Okay. We'll talk about it as we go further along about what that graph would look like. But that was a line. And again, I'm going to give you a line on the test. All right, and the next one is x equals t and y equals t cubed. Well, that's pretty easy. All I have to do is substitute back in for t, right here, t and x, and you get y equals x cubed. That's number 12. And that's it. That's going to be the rectangular equation. Then you could graph y equals x cubed and blah, 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 blah. All right, number 15 is going to be x equals the square root of t. And the other one is y equals 1 minus t. And again, what you do is you substitute back in for t in terms of x. What could you do? From here, you could square both sides. You have x squared equals t. So I'm going to substitute that value back in for t. T is equal to x squared. Let's be y equals 1 minus x squared. That's a parabola. Here I could write it this way, right? Negative x squared plus 1. You could see if I had to graph it, it's a parabola whose vertex is at 0, 1, and it goes down. You know, but anyway, hopefully it's not too hard to graph at this point in the game. And then 18 is x equals t cubed, y equals t to the 4th. And so this is 18. And what I could do is, remember, I gotta make this one say t equals, and then I can substitute back in for t. So if I take the cube root of each side, or maybe another way to say this is I could raise both sides to the 1/3. Okay, and then t cubed to the 1/3, those multiply together, just give me 1. So this would be x to the 1/3 is equal to t. So now I'm going to substitute back in for t here, and x to the 1/3. That would be y equals x to the 1/3 raised to the 4th. And again, when you multiply an exponent to an exponent, so you multiply exponents to x to the 4/3. So y equals x to the 4/3 would be my equation, and I could certainly graph that. Set up an xy table. Oops, sorry. Set up an xy table, you know, say with x0 and x1, x2, what would y be, and so forth. All right. What number was that? 18, 21. By the way, some of these are going to get wicked hard here in a second. And they're not going to be anywhere near that hard, excuse me, on the test, but I'm going to do them because trig meets parametric equations in a moment. Excuse me, in a moment here. And some of them are also have to do with logarithms. So you have to memorize your properties of logs. But here we go. We're going to see it when we get there. So 21, again, I got to make this say t equals and then substitute back in for t. This would be x equals, let's go ahead and distribute the 2. And this would be 2t plus 2. And then subtract the 2 from both sides. It's x minus 2 equals 2t. And then divide both sides by 2. And you get t equals x minus 2 divided by t. All right, let me just make sure I did that right. And that's it. Now we're going to go, wait. Divide, that's a 2. I can't even read my own writing. That's a 2, my bad. Divided by 2. Now we're going to substitute this value back in for t. Get back into this one right here. So this would be y equals the absolute value, and then for x, I'm going to do x minus 2 over 2, and then minus 2. Now, I wonder if I should leave it like that, or here, I'll go ahead and rewrite this. This would be y equals 1/2 x, right? Because I can break it up into 2 separate fractions. So it's x over 2, which is 1/2 x. And then negative 2 over 2 is negative 1. And negative 1 minus 2 is negative. So there's that one. All righty. And then you could graph that too. That's a v, right? That's a v. It's an absolute value, so that's a v. But we're not going to have to do that. Okay, here's where trig meets. Parametric equations, and it's a little rough. Here we go. Okay. For both of these, you have to solve for x. Wait till you see what this is, baby. That's an ellipse. That's an ellipse, if you can believe it. But here we go. Divide both sides by 2, and I would get x over 2 equals the cosine of theta. And I could divide both sides by 3 of this one, and I get y divided by 3 equals the sine of theta. And then you could, now what do we know? What do we know in trig? The biggest identity, the most common identity that we have is sine squared plus I would say, is sine squared plus cosine squared equals 1. That Pythagorean identity is the one that probably comes up most often. So I know that sine squared plus cosine squared must always equal 1, or x divided by 2 squared plus y divided by 3 squared has got to be equal to 1. And if you square this comes out to be y squared over 4, excuse me, x squared over 4 plus y squared, x, y, y squared over 9 equals 1. And hopefully you can see it, right? That's an ellipse, if I had to graph it, but you don't. That's an ellipse that, from the center at 0, 0, you have to go up 3, down 3, right 2, and left 2. Okay, let me hit pause. I'll be right back. Okay, guys. So that was number 24, 27. Same concept here. Same concept. I believe that is an ellipse as well, but let's try it. Yeah, it is. It's just not the center is not at 0, 0 this time. So at the origin. Subtract a 1 from both sides. X minus 1 is equal to cosine of theta. And subtract a 1 and divide by 2. Excuse me, that'd be y minus 1 divided by 2 is equal to sine of theta. I did skip a kind of an algebra step. Subtract a 1, then divide by 2. So I did skip one step. Now, sine squared plus cosine squared equals 1 again. So that's going to be y minus 1 squared over, start again, we write it differently. It'd be y minus 1 over 2 squared plus sine squared plus cosine squared equals 1. It'd be x minus 1 squared equals 1. So this would be y minus 1 squared over 4 plus x minus 1 squared over 1, if you want to write over 1, equals 1. And again, this is an ellipse. The center is at 1, 1. And from 1, 1, you'd have to go right and left 1, right 1, left 1, and up and down 2, up 2, down 2. You could graph it if you wanted to. All righty, and 30. Yeah, now 30 is where it starts getting into, this is exponential kind of growth. And so here we go. But it's the same concept. Oh, okay. Okay, here we go, Maddie. Here we go. This is going to be kind of rough, you guys, especially if you don't remember your properties of the function. So if I remember what I have to do is I have to solve for t here. Solve for t, and then substitute that t value back into here. So if you remember, when the unknown is an exponent, that's when logs become very, very useful. So I'm going to take the log of both sides. And if I take the log of both sides, the natural log of x equals the natural log of e to the t. And then again, remember, this rule says I can bring that t to the outside. It's the exponent rule, which allows me to go either direction. But this time I'm going to bring it to the outside. And then the natural log of e is 1. So this is the natural log of t. Okay, I've solved for t. Now I'm going to substitute that value back into this equation. It's going to get kind of rough here. It's going to be y equals e to the 3, and then for t, for t, I'm going to put the natural log of x. And so far, so good. Got to continue on with our laws of logs, and I'm going to use the exponent rule again, which means that's going to go, that 3 is going to go as the exponent. This would be e to the natural log of x cubed. And then I think it's called the inverse property. This would say that y equals x cubed. That just says when you have e, it's like the e and the natural log both cancel. In reality, I could prove this is right by taking the natural log of both sides, but But I'm not going to show that. But I'm not going to show it because then I'm really doing an exercise from chapter 3, I think it was, and explaining why that's true. And I don't want to go back to logs if that's okay. But that is true, right? It's called the inverse property. I'm almost positive. And so this would just be x cubed. So y equals x cubed. Okay. And 30, what am I doing? 36. I have to go to a new piece of paper very soon. Again, I got to make this say t equals. So this is going to be subtract the 4. I get x minus 4 is equal to t. Substitute that value back into t. And this would be y equals x minus 4 squared. That is a parabola that has been translated 4 to the right and 0 up and down. Right? But you don't have to graph it. That's all that I'm looking for on the test. Okay. And next, 39. You know what we need to do, and hopefully they'll be in here, because if it's not, I need to do it. But where there's ones where it's in rectangular form, and you got to give me the parametric equations. And I don't see any like that. So I need to maybe create some for you. It's just hitting me. Oh no, I see some. I do see some. Okay, hopefully that, I don't know what the homework is, but if it doesn't hit it, I'm gonna have to make sure I get it here. That was 36 on 39. Pretty easy. I can divide both sides by 2, and this would be x divided by 2 is equal to t. And then substitute that value for t back in. Zoom in a little closer, maybe. Substitute that value for t back into here. This would be y equals t is x, absolute value of x over 2 plus 1. I'm going to tell you, I would factor out a 1/2. Let's leave it like this. This is a-okay. But if I had to graph it, and you don't, let's be clear. This would be y equals absolute value. I'd factor out a 1/2. And this would be x plus 2. And then now it should be clear. I hope it would be clear to see that this is a v, absolute value after all. This is a v. It's been translated 2 to the left, and it's been horizontally expanded by a factor of 2. So it's been stretched this way. Let me get my camera. This way by a factor of 2. Okay. But you don't have to graph it. I mean, that's a different chapter. That was IM2. And even in IM2, we didn't have horizontal expansions or compressions. Anyway, more than you need to know. 42. Okay, same kind of a problem. Let's start again. So for 42 here, I'm going to write it up here because it's just getting harder to write down there. So it's x equals 4 plus 3 cosine of theta. And y is equal to -2 plus 2 sine of theta. Boy, do I wish I could tell you what those are, but those are something in polar equations. But anyway, here we go. We haven't gotten there. Go ahead. Remember, we got to make this say cosine, make this one say sine, and then we're going to do sine squared plus cosine. So if I subtract, in this one, let's do x first. I subtract a 4 from both sides. And then divide everything by 3. I would get x minus 4 divided by 3 equals the cosine of theta. And for y, if I add a 2, y plus 2 is equal to 2 sine of theta. And then divide everything by 2. This would be y plus 2 divided by 2. 2 equals the sine of theta. And then keeping in mind the Pythagorean identity that says that sine squared plus cosine squared equals 1. So let's do that. So sine squared should be y plus 2. Y plus 2 over 2 squared, that quantity squared, plus x minus 4 over 3 squared, that's what cosine is, equals 1, which is y plus 2 squared over 4 plus x minus 4 squared over 9 equals 1. And you can see the center is at, the center is at 4, -2. And from the center, I'd go 3 left and right. I'd go 2 up and down, dots, 45 is x equals 1/2 t. You write 45. I should really write all of them because sometimes I go back to videos. I'm like, Brian, which one do you want? I can't tell because I want to see it zip past me. And this is going to be y equals the natural log of the quantity t squared plus 1. Hello. And so same concept. I have to make this say t equals. So if I multiply both sides by 2, I get t equals 2x. Okay, I think I got it. Give me a second. Well, let me just move forward and see if I got it. It's going to be y equals the natural log of, and for t, I'm going to substitute in a 2x squared plus 1. In which case, this is y equals the natural log of the quantity 4x squared plus 1, right? Because you got to square the 2 and then square the x. And then, I don't know. That might be it, because that is that's y in terms of x. So let me look in the back of the book. Okay, guys, I just looked in the back of the book, and because it didn't give me the equation, but that's what I want you to do, because it's what you're gonna have to do. Not anywhere near this hard. This is right. I know it's right because I looked and they do give you the equation. Excuse me, the graph of it. And the graph of it does equal this. So it's got to be right. So I know it's right. Okay, and now my problem is I don't know what the next problems are. So I have to hit pause again. Okay, we're in there. So 63 to 75. Oops, I wrote it down here. So 63 to 75 multiples of 3. This is like the other, if it's the year 2022, but if it's another year, you're gonna have to ask me separately. It's like the other question. You're gonna see how simple these are. They're kind of laughably easy, I think. Anyway, here we go. So this is going the other way. Remember what we did before is we had a set of parametric equations and we had to write a singular rectangular equation, y in terms of x, right? This is x in terms of t and y in terms of t, two parametric equations. Now I'm going to be giving you a rectangular equation, and it says 63. And there is a part A and B, but they go so fast that it shouldn't take too terribly long. It says for all of them, for part A, should have written this down, let t equal x, and for part B, let t equal 2 minus x for all of these problems. So for 63, that's for all these problems that in this group of problems. This is going to be y equals 2 minus x. So for part A, what is x in terms of t? Hell, they already told me. X equals t. They already told me. And for y, it's y equals, all we have to do is substitute for x at t. You go, fine, wait a minute. Is it that easy? Yes, it is. That's part A. Part B is going to be let x equal, okay, we have to solve for x. In fact, let's do that right now so we can use that every time. We can add an x to both sides and subtract a t, and we get x equals 2 minus t, right? If we solve for x here, x equals 2 minus t. So x equals 2 minus t. There we go. There's x in terms of t. This is my set of parametric equations. And now we have to write y in terms of t. Well, what am I going to do? I'm going to take my equation and I'm going to substitute for x. I'm going to substitute for x a 2 minus t. So let me box this one. That's x in terms of t. And this is going to be y equals 2 minus the quantity 2 minus t. Holy smokes. Okay. So that's going to be, that's going to be 2 minus 2. Well, let's just do it. It's going to be 2 and then distribute the negative sign. This will be negative 2 plus t, and then 2's cancel. And you just get y equals t. So there's my set of parametric equations for those. 66. And it says for part A, well, it doesn't matter for both of them. We're using the equation x equals 3y minus 2. Okay, let's go ahead and solve for y. This says x, right? We want this to say y equals. That should be pretty easy. We'll add a 2 to both sides. That'd be x plus 2 equals 3y. Divide both sides by 3. And we get y equals x plus 2 divided by 3. All righty, so for part A, if you remember what our requirements are, it says let x equal t. So there's x in terms of t. That's pretty easy. X equals t. That's going to be that every time for part A. And then for part B, all we have to do is substitute that value for t back into this equation. Duh. Y equals t plus 2 all over 3. And those are my set of parametric equations for this one. Now for part B, it says that to let x be 2 minus t. So here we go. X equals 2 minus t. And again, for part B, that's always going to be x. That was the requirement that it told you at the very top of the problem for all of these. Go ahead and let x be, well, it says t in terms of x. So I just switched around. And now we're going to substitute in this equation right here, where I have an x. I'm going to substitute a 2 minus t to be y equals 2 minus t plus 2 all over 3, which is y equals negative t, 2 plus 2 is 4, all over 3. This would be my other parametric equation to give me my set of parametric equations. Okay, 69 is y equals 3x squared plus 1. So for part A, my x value, it says let t equals x, or x equals t is another way to say that. And then I substitute in for t, or add x here, be y equals 3t squared plus 1. Ta-da! That easy. And for B, this is going to be, let's see, where this x equals 2 minus t. And then again, I have to substitute in for x, 2 minus t, and then I'm going to simplify. It's going to be y equals 3 times 2 minus t squared plus 1. Again, for x right there, for x, I just substitute this value. And it's going to be y equals 3 times, let's go ahead and expand this. And this would be 4 minus 4t plus t squared plus 1. And then we got, it's going to be y equals, distribute the 3. It's going to be 12 minus 12t plus 3t squared, and then plus 1. And then let's go ahead and write it in standard form. That's going to be 3t squared minus 12t. I think I forgot the t here. Plus sign. What terrible writing for 12t. And then I got 12 plus 1 would be 13. And that would be that equation. And 72. 72, the equation is y equals 2 minus 5x squared. So for part A, it says to let x equals t, and y equals, substituted for t here, 2 minus 5t squared. So part A is always super simple, right? Part B would be, okay, where is it? It's x equals 2 minus t is what they say to use, which means now I got to substitute that value of 2 minus t back in for x, and then it's going to take a little bit. Let's see if I do better in terms of my neatness. 2 minus 5 times 2 minus t squared. So you can bear it down. So y equals 2 times negative 5 times down this 4 minus 4t plus t squared. That's better looking. It's going to be y equals 2, distribute the negative 5, it's going to be minus 20. It's going to be plus 20t, and it's going to be minus 5t squared. Writing it in standard form, which means descending order of exponents, will be negative 5t squared plus 20t. And then 2 minus 20 is negative 8. And there's that one. 75. For part A, the equation is y equals e to the x. See it? The equation is e equals y equals e to the x. So the first parametric equation says that x equals t, which means that y equals e to the t. There they are. All right, just substitute it, let x equal t, and then wherever you have an x, put a t. Bam. And for part B, it is x equals 2 minus t, which means that y equals e to the 2 minus t as your exponent. And I don't think you can do anything with that. That's as far as you're going to be able to take it. Okay, and here we go, 93 to 97. These are extra credit level kind of questions. Here we go. Let me show it to you. This is the honest to goodness when you're in a physics class, high school level physics class, I might add. And it is in real life. This is your projectile motion in terms of parametric equations. What's happening in the x direction? What's happening in the y direction? In time, in terms of time, you can see t is the variable here. Yes, there's a theta. Theta represents the initial angle that the projectile is shot at, or if it's a ball where it's thrown at, or whatever. V sub 0 represents the initial velocity, so how hard you throw it, or how fast it's shot out of a cannon, or whatever. H represents the initial height. And I think I got all the things, right? Theta is the angle in which you throw it or shoot it or whatever, right? Now, if you notice here, right, that's a pretty simple equation. And that's because it's just going along, and, you know, Newton says that if no force is being applied to it, once you let go of that ball, or after it's out of the barrel of a howitzer or whatever, then it's just, you know, Newton's driving it. It's just going to go at some constant speed. You know, and so, but now in the y direction, there is a force acting on it. That's called gravity. If it was out in space, right, then we can get rid of that whole final thing. In fact, there's out in space, there's no initial height either, right? So unless we want to give some reference, but nah, let's don't. So it would become pretty simple out in space too. But we're talking about something that's being fired or thrown or shot here on Earth, and it's this is in feet. So the gravity is 32 feet per second, pulling down on it. Anyway, so that's it. Okay, that's it. And of course, the height, you have to give it some initial height. Y represents the y direction of it. Okay, here we go. I haven't even read the question. Use a graphing. We're not using a graphing utility. Are you out of your? We're gonna do what we got. Skills, man. We got skills. Utility should graph the paths of projectiles launched from the ground. For each case, use the graph to approximate the maximum height and the range of the projectile. Okay, let's see if we can do that. So the first thing is we're going to substitute some values back in, right? Oh, and I think launched from the ground. Launch from the ground means that height is 0. The initial height is 0. That is going to make it easier. All right, so in the x direction, it's going to be v sub 0, which is 88, times the cosine of 60 degrees, p. And oh, by the way, the cosine of 60 degrees, this is for A, 66, or excuse me, 93A. I'm curious, you know what I think, you guys? Because these are borderline extra credit kind of questions. In fact, they probably are. I could do this 4 times, right? Just different numbers. But I think I'm just going to do 1. Okay, I'm just going to do 1 of these and then move on to 95, because this does take quite a while. Okay, and so that's it. That's what x is in terms of t. Parametric equations. That's parametric equation. The initial height is 0, so h is 0. V sub 0 is 88 times the sine of 60t minus 16t squared. So those are my parametric equations. Now, okay. This is ugly, but here we go. This is, I don't know any, but remember, we have skills. So when they say, hey, grab a calculator, I'm like, you can keep your damn calculator. I can do this. Here we go. What do we know? We know that if we shoot a projectile off from the ground, it's going to have a height of 0 twice. It's going to have a height of 0 at time equals 0. And it's going to have a height of 0 at some other time that we want to know. But the height of it, once it reaches its final thing, the height of it is going to be 0 right here, right? So what if we set the height to 0 and solve for t? Let's do that. This would be 0 equals 88. The sine of 6, I could do the sine of 60, or I know the sine of 60 is root 3 over 2. I think I'll just put it in there. I can just punch numbers in the count. I guess it's just easy to put sine of 60. Minus 16 t, forgot the t here, t, minus 16t squared. Now I can factor out a t here. This is going to be 0, right? They each have a t. This would be t times 88 root 3 all over 2 minus 16t. Well, we know that the only way you can get 0 when you multiply two things together is if one of them is a 0. So we set each of the factors to 0. Set t equal to 0, t equals 0. Yep, we knew that was going to happen. We knew at time 0 it was going to be 0. And then we have to figure out what value of t makes that 0. So it's going to be 88 root 3 all over 2 minus 16t equals 0. You can keep your damn calculator. I can do this. Add a 16t to both sides, and I get 88 root 3 all over 2 equals 16t. Divide both sides by 16, and t is equal to 88 root 3 divided by 32. Now, that's the time that when it's going to reach a height of 0. So if I take that time, that exact value for time, and I plug it back in to this equation, that's going to tell me how far it goes. That's going to be the range that it goes. So let's do that first. Here we go. So I'm going to do 88 times the square root of 3. By the way, I don't think I'm going to check my answer, because if I'm wrong, I know my logic is right. And so I just did some algebra wrong. I'll check it. And then t, and t we said, well, that was t. Got it. So that's going to be times the cosine of 60, which we know is 1/2, times 88. At least I hope you know. All right, so okay, I know it can't be negative, and yet I got a negative answer. So I did something wrong. So it's going to be, let me try numbers again. 88 times the square root of 3. I'm in degrees, I just want to make sure. Divided by 32. There's the time, times the cosine of 60. Close the bracket. Maybe that's what I did wrong. Times 88, I bet it is. And yeah, that's how I'm getting it. So I'm getting 209.6. And I believe this was in feet. I think the units were given to me, yep, feet per second, so feet. That should be the maximum distance that it goes, about 209.6. You can see why I don't want to do this 4 times. Just get the concept, you can try it yourself. Let me hit pause, make sure that's right. Okay, indeedly do, as you kids say. Yep, just want to make sure it's going. I almost hit stop recording, that would have been screwed up. Anyway, so now let's do some more logic here. That was the right answer, 209.6 feet. And now let's do some more logic. The other logic is, okay, I'm starting to think maybe extra credit here. We'll see. And so we know that if it's shot from the ground, that it's going to reach its maximum height at the middle, right in the middle, because these things are symmetrical, right smack dab in the middle. What's right smack dab in the middle? Well, we know the distance from here to here in terms of time is 88 root 3 over 2. Excuse me. Yeah, 88 root 3 over 32, my bad, over 32. That's the time it's going to take. So if I divide by 2, or take 1/2 of that, that should tell me the time when it's at its maximum height, which is obviously where it's going to reach its middle right here. That middle point is going to be equal to 88 root 3 over 64. And if I take that time and figure out what is the height in the y direction at that time, here we go. Now I have to substitute for t here and t here, this value. Okay. Now I think what I'm going to do is I'm going to store that. Tell you what, I'm going to store that. This is, what time is it? It's going to be 88 times the square root of 3 and divided by 64. And I'm going to store that value just so I can use it anytime I want to, which is 2.38 seconds. So after 2.38 seconds, it's going to be at its maximum height. Here we go. I'm not even sure this is the best way to do it, but I think it is without a calculator. All right, here we go. I'm going to substitute that value here. So I got 88 times the sine of 60. I did cosine, sine of 60, times that stored value. And I'm going to hit equals. It says 181.5 right at the dot. Beautiful. Minus, and in brackets, I'm going to do 16 times that stored value squared. 16t squared. Look at it. And I'm getting 90.75 right on the dot. 90.75. I had this. It says 90. It says 90.7. I'm going with 90.8 because you're supposed to move a 0.5. Anyway, I think we got the same thing basically. They said 90.7. Technically, that should, if you're going to round it, that should be 90.8. Okay, but that's it. Okay, good enough for that. In fact, I'm kind of thinking good enough for the whole thing, but let's do a couple more. These are fun. If you're me, the center field fence at Yankee Stadium is. I'll check my answers on this one too. It's 7 feet high and it's 408 feet from home plate. The baseball is hit at a point 3 feet above the ground, and it leaves the bat at some angle theta at an initial speed of 100 miles per hour. Oh, crap. Okay. Here's what I'm thinking. I'm thinking that I'm giving things in feet here, right? Where it hits off the ground is in feet, and where it's hit off the ground is the height of the fence is feet, and how far away the fence is in feet. And then they give me this damn miles thing. That's problematic because all the units have to be the same. Okay, here we go. I wish they had done it. I wish they hadn't been so cruel here. So this is number 95. Let's start with converting 100 miles per hour into feet per second. So if I've got 100 miles per hour, this is a dimensional analysis thing. If you're taking chemistry, there's going to be 5,280 feet in 1 mile, and the miles cancel. And if you don't mind, I'm going to do this. In 1 hour, there are 3,600 seconds. I don't know if you guys know that. There are 60 seconds in 1 minute, and there are 60 minutes in 1 hour, and 60 times 60 is this. So there's that many seconds in 1 hour. And then the hours cancel the hours, and now I'm in feet per second, which is where I want to be. All righty, let's do it, and then I'll get a number for that. It's going to be 100 times 5280 divided by 3600. And it is 146 2/3 feet per second. That thing is screaming off the bat. That thing is screaming. All righty. Well, 100 miles an hour, after all. All right. So actually, I'm going to store that value. So it's an exact value. Store it in A. Here we go. And now let's get the two parametric equations, just so we have that. So it's x is equal to the initial velocity, which I said was 146 2/3 feet per second, cosine of theta t. Can't see it. That's in the X, that's this direction in terms of t where it is. And y is going to be equal to the initial height. I don't remember what it was. It's hit off the bat 3 feet above the ground. So 3 plus the initial velocity, 146 2/3, times the sine. Oh, did it give an angle? It didn't. It's going to in a moment. Theta t. So theta is still a variable. Theta t and minus 16t squared. And I think that's what we had to do first. Write a set of set of parametric equations. And it says to go back to those equations. If you need help, go back up here to just start substituting back in. Alrighty, keep going. And it says use a graphing utility. Nope. Use a graphing utility to graph the path of the baseball at 15 degrees. Is it a home run? Let's not graph it. Let's just see, is it a home run if theta is 15 degrees? Okay. Well, what I could do, I could see what is the height. Oh, that's not going to work. I don't know. Let me think about it for a second. I was thinking I knew, but for a second. Okay, it's pretty convoluted logic. I don't know if it's convoluted. That's not the right word, but it's pretty extensive logic. But here we go. Here are my two parametric equations. Here's what I was thinking. We want to know at what time is the ball going to go 407 feet? So if it's at 407 feet, because that's how far away, remember X, that's how far away the fence is. And at what time is that going to happen? Remember, it looks like this, right? So now, if at the time, here's time 0, because remember it's 3 feet off the ground, whatever. So if I find out that the time that it's 7 feet high, because the wall is also 7 feet high, if I find that the distance at 407, right, where it goes 407, if that time is such that it's 7 feet high, then that's good, right? Then that's going to be a home run, or, that's it. But if the time it gets to 407 feet, the ball is here, then that means that this here, right, here's the wall over here, that's 407 feet. And so, right, I'm going to get some negative height, which means, oh, it didn't make it to the fence. So here's what I'm going to do. I'm going to set the length of the ball to 407 equals 146 2/3 cosine. It says 15 degrees. Would it be a home run if it was come off the bat at 15 degrees? And now we have to solve for t. And I just did this a second ago, so let me just show you. If you divided both sides by the cosine of 15 and divided both sides by the initial velocity 146 2/3, it would be this. It would be after. Yep, it was this. It would be after about 9 seconds. It'd be after 2.9 seconds is when it would be 407 feet. So then I took that number and I put it back into here and said, okay, after that much time, after how much time, that much time t, and again, putting in 15 seconds here, and t, that same time that I just found 2.9, actually it's 2.879950, you know what I'm saying, the exact value. When I put it in here and put in a 15 there, my height came out to be when I just did it, here, I'll do it and show you. It was 3 plus that, the initial velocity times the sine of 15 degrees times that time, that 2.8, so that's 2.9 seconds. I'm going to hit equals just for the hell of it, minus, and then I've got 16t squared, so it's going to be 16 times that stored value squared, and it comes out to be negative 20 feet. That means, if the ball could keep, if the ball could keep going, at that time that it goes 407 feet, it's going to be 20 feet below the ground, but it's not, of course. It's going to hit this thing here and keep going. You know, it's not going to make it to the fence. So the answer is no. The answer is no. All right, now I'll show you this. Let's do one more and call it a day. All right, let's not do part C or D. I think now there's a football one. All right, here, let's just do these. What the hell? I don't care. It's taking a long time. You can choose to not watch this or whatever. Maybe I'm just speaking to only me. It says, what if that angle was 23 degrees? Now I need to keep those equations near me here somewhere. Where are they? God damn it, fine. I suck. All right, hold on. Let me hit pause and find where my paperwork is. Okay, it says, what if it was at 23 degrees? Here we go. So that would be, is the ball going to go 408 feet? I'm not sure if it did 407 last time. Whatever, it's would have come out to be pretty close to the same. 408 wouldn't have been a home run. 146 2/3 cosine of 23 degrees, I think it was. Yep, cosine of 23t. And if we solve for t, that's going to be 408 divided by the cosine of 23 divided by the initial velocity. Yeah, that's going to be something that it can't possibly be. So let me do it again. It's 408 divided by the initial velocity and divided by the cosine of 23. There it is. So it's about 3 seconds this time. It's going to reach that 408 feet after about 3 seconds. We store that value in that other locations I had it before. And we're going to see, you know what, if I plug that time in, if I plug that time into here and here, at same time that it's going to be at 408 feet long, is the height at 7 feet at that point. So let's go ahead and plug that back in. God, I love this stuff, but hope you guys do too, but I doubt it very much. It's going to be, as much as me anyway, 3 plus, in brackets, that initial velocity times the sine of 23 degrees times that time, 3 seconds about, and let me hit equals. And this is going to be, remember, we're looking for this number to be 7 or more. Because remember, when the ball is that far, it needs to be still 7 feet high, because the fence is 7 feet high. And it's going to be minus 16 times that stored value squared equals. That says no. But I think the answer was yes. All right. No? Yes. It says yes. Okay. Let me hit pause and just maybe I hit buttons wrong. Just give me a second. Because I think my logic is right. Okay, so I just redid it. I just repunched in numbers, and it says that the ball at that time after 3 seconds would be at 30 feet. Would be at 30 feet high. So it's going to clear the fence easily. It's going to clear the fence easily. And then the last question says, what would be the minimum angle required to hit the home run? Okay, let me hit pause, and we might skip it if Freund can't figure that out. Okay, so Freund's conceding, because short of a graphing calculator, I don't know how you would do that. And that's maybe it does say to use a graphing utility. With the graphing utility, you could certainly do that, but I was trying to do it without a graphing utility. And here we go. Let's do the football one. Again, if you cut me off, I get it. All right, let's see here. So the football one says a quarterback releases a pass 7 feet above the playing field, and the receiver catches the football to height. 4 feet, 30 yards down the field. And the passer is released at an angle 35 degrees to the horizontal. Okay, let's write the parametric equations first. So x is equal to v sub 0 cosine of 35t. So we don't know the initial velocity because that's not given to me in the problem. And y is going to be equal to the initial height released at the top 7 feet above the ground. 7 plus v sub 0 sine of 35t minus 16t squared. Okay, we did part A, right? The parametric equations. So we did part A. Part B, find the speed of the football when it is released. That's v sub 0. All righty, so let me think about this. Crap, that's pretty, okay, here, I got it. I think I got it. Watch this, you guys. This is tricky. I'm gonna make this the last one. I'm done. We're gonna make this part B the last one. Here we go. Because these are not gonna be any kind of a questions you get on the test. You can see that they take a long time, they're pretty hard. Anyway, here we go. So you can see I got v sub 0t, I got v sub 0t here. So what I could do is I could substitute for v sub 0t here, this, and then solve for t. And once I know t, I think this will work. And once I know t, then I could substitute back in for t here and figure out the initial velocity, I believe. Okay, let's do that. Let's try it. Here we go. So if I divide both sides by the cosine of 35 here, I get x over, okay, that's not going to work. Give me a second here. Give me a second, let me pause it. Okay, that didn't take me long, I just thought about it. So x represents how far down the field the ball has gone. And it says it's gone 90 yards down, 30 yards down the field, which is 90 feet. We've got to be careful, again, keeping units the same, because it's 7 feet above the ground and it's 4 feet. It's 4 feet above the ground. So let's keep everything in feet. So 30 yards represents 90 feet. So if I put a 90 in for x, how far down it is, it would be 90 equals v sub 0. And I'm going to put the t here. I'm going to just switch the order of these variables. And this is this cosine of 35. That didn't take me long. Divide both sides by the cosine of 35, and we get v sub 0t is 90 divided by the cosine of 35. Now, we could take v sub 0t, and for v sub 0t here, we could substitute that value in. Let's do that now. And this is going to be y equals, now let's talk about it. What is y? Y is the height of the ball. Y is the height of the ball when it's 90 feet down the field or 30 yards. And it says the person catches the ball at 4 feet high after it's gone down the field 30 yards, 90 feet. So I'm going to go ahead and substitute here for y. I'm going to substitute a 4 feet high is equal to 7 plus the initial velocity. Well, that's actually v sub 0t. V sub 0t, which we said v sub 0t was 90 divided by the cosine of 35 times the sine of 35 times the sine of 35 minus 16t squared. Well, okay, let's subtract a 7 from both sides. It's 93 is equal to, and by the way, sine over cosine, as long as it's 35 and 35, sine of x over cosine of x is tangent of x. That will make it easier. 90 tangent of 35 minus 16t squared. All right, let's let's subtract 90 times the tangent of 35 from both sides. Be -3 minus the quantity 90 times the tangent of 35 is equal to -16t squared. And divide both sides by -16. And the first thing I see is these negatives are going to cancel, and all those negatives are going to cancel, and 16s are going to cancel, and I just get t squared is equal to let's do that first. And then I'm gonna, remember, I don't want t squared, I want t. So once I find t squared, I'll have to take the square root to get t, and then we'll go from there. Let's get that first. That's gonna be 3, and I'll look at t, see if it's right. And I tell you what, again, if it's not right, my logic, I think, is pretty solid, and I'm gonna go ahead with, I just punched numbers wrong. Or no, I'm gonna get it right. I'm gonna insist on it. Here we go. 3 plus 90 times the tangent of 35 and divided by 16. And there we go. And that's t squared. Now I'm going to take the square root of that to get t, and there it is. So we store that value. And oh no, let's go raise it to 1. There we go. And store that value in. There we go. All right. Now I've kind of lost my place, but that's the time when, yeah. So that's the time when it hits that person at 90 feet. That's how long it's going to take. So now we can figure out the initial velocity by substituting it for t here. So it's going to be 90 equals v sub 0 cosine of 35 t, and we said that t value was about 2.03. So I'm going to put the exact value in. So v sub 0 is going to be equal to 90 divided by cosine of 35 divided by 2.03. And now let's think about what the units are. This is feet, right? And this in seconds we're talking about. So feet and seconds, this is 2.03 seconds. So feet per second is going to be our units for how fast that is. So it's going to be 90. This is such good stuff, man. 90 divided by the cosine of 35, close that bracket, divided by the stored value 2.03, and I'm getting 54, about 54.1 feet per second. All right, let me look in the back of the book. 97. Yes, it is. 54.09, but you know, yeah, I just rounded. 54.1 feet per second. All right. Drawing's done. Drawing out. I'll catch you guys in class, and I will see you later.